Are you capable of determining how much excess reactant is going to be left based on the information above? If not, stay with me until the end of this question and I'll teach you all about stoichiometric relationships
with one simple method. Let's go!
Which species are present after 15 liters, so this is a decimeter cube, but you can read it as liters, of buta-1,3-diene has reacted with 18 liters of hydrogen to produce butane. If these two react with each other, it just means that this weird guy is buta-1,3-diene and hydrogen gas is H2. They react and they'll produce pure butane. What I did is I rewrote this reaction with their condensed formulas. Buta-1,3-diene has 4 carbons and 6 hydrogens. It reacted with 2 moles of hydrogen gas. It yielded C4H10. So I translated all into this little table. So what you're going to want to do is you repeat the reaction here and you write the ratio. What is the ratio? It's the coefficients after the reaction has been balanced. So the coefficients are these numbers outside of the molecules. If there are none, just put the number 1. So the coefficients, the ratios are 1 to 2 to 1. And it says here the initial, so I put, but you can write the word initial, is I start with 15 liters of buta-1,3-diene, then I react it with 18 liters of H2, and of course I start with 0 liters of my product. Unless specified otherwise, I start with 0 products. Now here's how you infer how much it reacted. The ratio should be 1 to 2 or 2 to 1. So that means whatever amount of C4H6 that I put, I should react with at least double of it. Or you can look at it the other way. Whatever amount I put of H2, I have to react with half of it. So if I decided to put 18 liters of H2, I need to react with half of that. How much is 18 divided by 2 in order to go from 2 to 1? It's 9. So C4H6 is my excess reactant. Because if the coefficient is 1 to 2, I should have half of C4H6 than I have of H2. So I should have 9 liters of that to react with 18 liters of that. So therefore, this is my limiting reactant and it follows all the stoichiometry of that. So it's going to produce half of 2 in order to go from 2 to 1. I'm going to produce half of that. So 9 liters. And this is a product, right? So I add this column, I subtract this column, and I subtract this column because these are reactants and reactants get consumed. So all of my limiting reactant gets consumed. So at the end, I have 0 liters of hydrogen left. I have 9 liters of butane left. And I have 15 minus 9 liters of buta-1,3-diene left, which results to 15 minus 9 is equal to 6 liters. So at the end of the reaction, I have 6 liters left of buta-1,3-diene and 9 liters of butane. Alternative. All right, everybody, for more questions like these, follow my social media accounts at Mr. Diego Tutoring on Instagram and TikTok. And please also subscribe to my YouTube channel at Crushing Chemistry. If you want to schedule a tutoring session, no matter where you're at in the world, please DM me on Instagram. See you next time. Bye-bye.